Picking up from the second video here, in this last video, I want to show you exactly how I will have you run categorical variables in this class to make your life a lot easier, and because it will just be very efficient. But to wrap up from the previous thing we just done at the end of the second video, we had this whole huge mess of the interaction variables of neighborhood and square feet. And we know that it gave us a regression line for each neighborhood, each with its own different intercept, and each with its own slope, creating all of these different lines and differences and things that are going on. So all the interpretations for each thing are here, but I won't have you ever make a model this complicated and pick it apart this far. That's for a different class and a different purpose. I just want you to get a taste for that. So that's what all this stuff looks like. And I do want to point out an interesting artifact, actually. And this shows the importance of how we pick predictors and how we decide to eliminate things. So if you notice in our model originally of just neighborhood and price, all these things were insignificant. So we would exclude neighborhood right away. There's no reason to keep using neighborhood. But if I look at this really complicated model, notice that I actually get a statistically significant interaction term between neighborhood B and square feet. And suddenly neighborhood B is also statistically significant, all with respect to neighborhood A. Well, that's because once we throw all this garbage into the model, some weird things can start to happen, particularly when there is not statistical significance of our original variable to begin with. So this is why we don't look at a model like this and say, oh, well, this is significant, so I better keep this and just get rid of everything else. That wouldn't be a good way to go, because we would want to check to make sure first that the categorical variable on its own was statistically significant. So we wouldn't even get to a point of testing interactions to see this strange artifact, this strange result here. So there's a lot of stuff you could chop up here, but this was just to demonstrate what a complicated full interaction model like this might look like with a categorical variable. But functionally, the neighborhood variable isn't doing anything. Great. So these are 3 examples of how to use categorical variables with this manual entry of these indicator variables representing our neighborhoods. So what happens, though, if I just do decide to run a model of neighborhood, this crazy 4-category thing, this 4-category variable? What if I do decide to run a model of that, of price versus neighborhood? What does R do if I don't specify indicator variables? Well, let's run it and see what happens. What R does, R is smart enough to say, I see that you are running a categorical variable. I know that for this model to make sense, I need to exclude one of the groups. And that is what R has done. R has automatically excluded NA, neighborhood A, and it has given us neighborhood B, neighborhood C, and neighborhood D. For the purposes of doing this kind of modeling, this gave us the exact same result as plugging in my neighborhood separately. And if you see, if you mimic the model we did after that, where I included square feet and a bunch of indicator variables, like I'm doing right here. So let's add square feet to this neighborhood variable. R is also smart in this case to exclude one of the neighborhoods and give us the same model that we saw above. So all these results are still the same. Excuse me. Excuse my yawn. Long weekend. And if I want to make an interaction model, this whole big mess that I've made manually here, R is smart enough to do that if you simply type in the categorical variable and then our little colon there to signify an interaction and square feet. Now you'll see that R has given these things a slightly different name. R does not nicely just take the name of the category and drop it in there. R takes the name of the variable, neighborhood, and then the name of the category right after it. Neighborhood NB, neighborhood NC, neighborhood ND. But again, this is the exact same model, the exact same mess as what we got before. But now R automatically knows to exclude neighborhood A and do that. So a couple of points. One, for the purposes of this class, I want you to run categorical variables this automatic way. For our purposes, it does the job. It gets the job done. If you want to make indicator variables, you may absolutely do that. But for the purposes of this class, this is just an efficient way to do it, and it does what we want to do for our interpretations. So feel free, when we have categorical variables, to just leave them in like this. But you might have noticed something. How did R know to exclude neighborhood A? Why did R exclude neighborhood A and not neighborhood B, C, or D? Well, R has, when you import data, R automatically puts things in a certain order. So R read this variable, and for some reason, probably alphabetical order, it said, well, this categorical variable has an NA, an NB, an NC, and an ND. So I think R basically just puts it in an alphabetical order or some kind of sorted sequence, and it excludes the first one. So it excluded the thing first in alphabetical or in sorted order, which was NA. So this is one of the limitations of letting R do this, is that R chose for us. If I wanted to exclude neighborhood C, I could easily do that up above with my indicator variables by just taking out neighborhood C and instead making it neighborhood A and changing it wherever I needed to. So if you want to do this automatic method of categorical variables and you want to change the reference level that R has defaulted to in its program, you use a function called relevel. And I can let you read this. You can read that syntax. You simply change the reference level. So if you want to change the reference level from neighborhood A, NA, to neighborhood C, or NC, we just use the relevel command. And then we change the reference level to NC. Now when I run my model of price and neighborhood, now R, in its automatic magic, now that it has releveled neighborhood C to the reference level, knows to exclude neighborhood C. And now here we have neighborhood A. The intercept is representing neighborhood C. And my coefficients are now all with respect to neighborhood C. So my last comments are, well, get to the bottom here. So again, for this class, just use the automatic method. It's quick, it's fast, it does what we want to do. As you get into your research, or if you use this at any point going forward, there's a reason we don't rely on this nice automatic method. One, I don't know if other statistics programs are as convenient and nice as R. I don't know. I'd have to go check. I don't know if Stata or SPSS or SAS nicely excludes a reference level for you. It may require you to make these indicator variables. So you at least see here how you need to arrange indicator variables if you need to do that manually. So that's one reason, is not all programs may work the same. Another reason is that you may want to actually exclude more than two groups. And we won't get super far into that. Well, I don't think we'll get into this at all. But for example, we could have a case where we want to also exclude neighborhood C, and then we just have a model of neighborhood B and neighborhood D, and that would mean that, for example, if neighborhood C was statistically insignificant compared to A, then there's no reason to keep neighborhood C in the model, and we would just exclude it. And our reference level would be the combination of neighborhoods A and C, because there's no statistical difference between them. And our coefficients then that remain would be with respect to neighborhoods A and C in combination. Again, I'm not going to worry about that, but I just want you to know that with R automatically choosing variables, you don't have as much control over what groups go in or do not go in your model. For certain models where there are 10 groups, you may not need all those groups in your model to model appropriately. So you may want to exclude certain groups and not others. And so doing it with this indicator variable approach lets you do that. And lastly, if you take more statistics and you get into what's called a matrix algebra, which is the way R works with, so linear regression behind the scenes, behind the software, one of the ways it calculates everything is using matrix algebra and complicated algebra or calculus or some other methods. And if you need in an advanced class to do the regression with matrix algebra and outside of an LM function or something that nicely does things for you, you will need to make your indicator variables on their own in the matrix. So anyway, I don't need to belabor that point. Point being, once we get in more complex situations where LM function no longer works or applies, there's no more automatic nice thing that can be done with categorical variables. We just need to make the indicator variables for each category and then do whatever manual behind the scenes work needs to be done. But we're not going to confront that in this class, but just know that it's out there in more advanced situations. So for our purposes, the automatic way is nice. It gives us what we need. Once we move beyond that, you have to do more of this manual approach. And you know what? I think this makes good interpretive sense. Each neighborhood has its own variable. I like that. I think that's pretty intuitive. So I don't think it's too crazy to think about it in that way. But for now, just run things in the very simple automatic way by including the categorical variable on its own without doing indicator variables. It will work for our purposes. But again, you can